A candle once revealed whether you were rich or poor, measured time while you slept, and sent ships across entire oceans to hunt whales. But its story began with a far simpler problem. How could humans bring fire indoors without losing control of it? Early civilizations experimented with reeds soaked in animal fat, bowls of oil, and primitive wicks. Then someone discovered a remarkable system. Surround a wick with solid fuel, and the flame could feed itself. Heat melted the wax. The wick pulled it upward. The vapor burned, melting more fuel below. It looked simple, but the fuel surrounding that wick would divide candlelight into two completely different worlds. One belonged largely to churches and wealthy homes. The other would define the nights of the poor. In medieval Europe, darkness was not equal. Poor families usually burned tallow candles made from rendered animal fat. They were affordable, but they smoked, sputtered, softened in warm rooms, and filled cramped homes with the odor of burning grease. Even rats could be drawn to them. The wealthy burned beeswax. Beeswax candles gave a steadier flame, produced less smoke, and carried a faint sweetness instead of the odor of slaughtered animals. But they were expensive, placing their clean golden light largely inside castles, wealthy homes, and churches. So night itself became a measure of class. A poor family might ration a single weak flame, ending work when the candle became too expensive to continue. The wealthy could illuminate entire halls and purchase something the poor could not, more hours after sunset. But candles were about to do more than separate rich from poor. By marking the wax itself, people discovered they could watch time disappear and even make a flame sound an alarm. Before reliable clocks, people learned to measure the night with fire. First, they marked candles into equal sections. As the flame moved downward, each vanished line represented another hour. Second, metal pins could be pressed into the wax. When the candle burned to a chosen point, the pin dropped onto a metal plate, creating a simple alarm with no gears, springs, or electricity. Predictable burning suggested another possibility. If carefully made candles produced similar flames, their light could be compared, not to measure time, but brightness itself. Soon, engineers would begin using a candle flame as a ruler for light itself. Once carefully made candles could produce relatively consistent flames, engineers and experimenters began using them as rulers for light. Special candles were made with controlled materials, weight, and dimensions. Their brightness became a reference for comparing lamps, streetlights, and even lighthouse beams. The idea survived in the term candle power, which compared a source's luminous intensity with that of a standardized candle. But creating a reliable standard was difficult. Tallow smoked, smelled, and burned unevenly. Beeswax gave a cleaner flame, but it was too expensive and scarce for widespread use. The ideal candle needed to burn brightly, remain firm in warm weather, and produce almost no odor or smoke. No widely available material could deliver every quality they wanted. Then they turned to a substance found inside the enormous head of the sperm whale. It produced one of the finest flames the world had ever seen, but obtaining it would turn peaceful candlelight into a global hunt. Inside the enormous head of a sperm whale was a waxy substance called spermaceti. It made exceptional candles, bright, firm, nearly odorless, and far cleaner than tallow. Wealthy homes could now enjoy a steady white flame, but every elegant candle began with a brutal hunt far out at sea. Whaling ships crossed entire oceans, sometimes for years, chasing animals whose bodies would be processed into lamp oil, lubricants, industrial materials, and candlelight. A peaceful candle on a dinner table could contain the remains of a creature killed thousands of miles away. But this cleaner light remained a luxury because every supply depended on ships, years of labor, and the death of more whales. Then chemists found a way to manufacture a cheaper flame without hunting anything at all. Whales had produced a cleaner flame, but chemistry was about to make them unnecessary. In the 19th century, chemists isolated stearin from fats, producing harder candles that burned more steadily and resisted warm temperatures. Then came paraffin, a pale, nearly odorless material that could be refined cheaply on an industrial scale. Paraffin was cheap, clean, and ideal for mass production. Its weakness was softness, but mixing it with stearin solved much of the problem. For the first time, factories could manufacture thousands of nearly identical candles, same shape, same weight, same predictable burn. Light that had once belonged mainly to churches and wealthy homes became affordable to ordinary families. Chemistry had finally created the most affordable and practical candle in history. But while factories were perfecting the candle, cities were building systems designed to replace it. What happens when an invention reaches perfection just as its original purpose begins to disappear? By the late 19th century, candles were cheaper, cleaner, and easier to produce than ever before. Then cities began replacing them. Gas lamps flooded streets, factories, and theaters with more light than dozens of candles could provide. But gas brought heat, smoke, leaks, and the constant risk of fire. Electricity solved those problems even more brutally. A bulb needed no wick, produced no dripping wax, and could fill a room at the turn of a switch. For the first time, extinguishing a candle did not mean returning to darkness. Within a few generations, candle makers went from supplying a necessity to selling an increasingly outdated object. The candle had lost the job it had performed for centuries. By every practical measure, it should have disappeared. But it did not. Its flame remained in churches, funerals, birthday rituals, vigils, and private moments of grief or hope. The candle was no longer valued because it was efficient. It survived because it was fragile. A bulb delivers light without asking us to notice it. A candle flickers, reacts to the room, and makes even a quiet moment feel temporary. The qualities that once made it inferior, weak light, limited fuel, and an exposed flame, gave it a new emotional power. But that emotional power begins with a physical process most people never see. To understand why candlelight feels alive, we have to look inside the flame. A candle flame looks still, but inside it, a chain reaction is happening every second. The flame first melts the wax. The wick then pulls that liquid upward through tiny spaces. Heat turns it into vapor, and it is this invisible vapor, not the solid candle, that actually burns. Even the flame has hidden layers. Near the wick is a dark zone filled with unburned fuel. Around it, glowing carbon particles create the familiar yellow light. At the outer edge, oxygen completes the combustion at the flame's hottest point. The flame creates the heat that melts and vaporizes the next supply of fuel, allowing the reaction to continue almost by itself. It is an elegant system. The flame produces the conditions needed to keep the flame alive. But hidden inside that system is one final paradox. The process can continue only while the candle beneath it is changing, and that paradox would give this obsolete object a meaning no electric bulb could reproduce. From tallow and beeswax to spermaceti, stearin, and paraffin, humans repeatedly rebuilt the candle. Then gas and electricity replaced the purpose it had served for centuries, yet the candle survived them all. We still light it for birthdays, prayers, love, grief, and remembrance, not because it defeats darkness better, but because it gives light a visible lifetime. A bulb can shine without appearing to change. A candle survives only by disappearing, transforming its own body into light, until nothing remains. That is the secret humans preserved for centuries. No other light shows us its own ending, and reminds us so clearly of ours. The next time you light a candle, remember what stands behind that small flame: smoky tallow in poor medieval homes, beeswax glowing inside churches, whaling ships crossing distant oceans, chemists manufacturing paraffin, and electricity that should have made the candle disappear. Which part of this history surprised you most? The way candlelight revealed social class, the whale hidden inside an elegant flame, or the fact that invisible wax vapor is what actually burns? Share your answer in the comments, and tell us which ordinary object should be investigated next. Subscribe for more hidden histories of the objects that quietly shaped human civilization.